Question 4. A large college produces 3 magazines. One magazine is about green issues, one is about equality, and one is about sports. A student of the college is selected at random, and the events G, E, and S are defined as follows. G is the event that a student reads the magazine about green issues. E is the event the student reads the magazine about equality, and S is the event the student reads the magazine about sports. The Venn diagram, where P, Q, R, and T are probabilities, gives the probability for each subset. Part A, find the proportion of students in the college who read exactly one of these magazines. So those that read exactly one are these 3 values here. So the 0.36, they read only sports, 0.08 read only green issues, and 0.09 read only equality. And so the probabilities of reading exactly one is the sum of those 3 probabilities, which is 0.53. No students read all 3 magazines, and the probability of reading the green issues magazine is 0.25. So we can label straight away on here, no one reads all 3. So the intersection of all 3 in the center here is P is going to be 0. Part B, I want to find part I, the value of P. Well, okay, so that's 0. And II, the value of Q, which is this intersection. So Q would be the probability of people reading green issues and sports. Well, I we've already answered. P is equal to 0. But now we know that of all the people reading green, the probability of reading the green issues is 0.25. So all 4 of these values should add up to 0.25. And we know that the sum of these 4 to be 0.08 plus 0.05 plus 0, which is P, plus our value Q. And that equals 0.25. So our 0.25 is equal to 0.13 plus Q. Subtract 0.13 gives us a Q value of 0.12. And we can pop that on the diagram as well. It may help us later. Given that S given E is equal to 5/12, so this is the probability that S occurs given that E has already occurred. Find part I, the value of R, and then II, the value of T. Okay, so let's start by writing our given that formula. So if we've got the probability of S given E, that is equal to the probability of S and E divided by the probability of E. Now, we know the probability of S given E to be 5/12. The probability of S and E would actually be 0 plus R. In this case, however, we've only got R because P is equal to 0. And then the probability of E is the sum of all of these values here. So that's 0.05 plus 0 plus R plus 0.09. And so we can start to rearrange this. If we multiply both sides by 12, and then also multiply 0.14 plus R, so we'll have 5 lots of 0.14 plus 5R is equal to 12R. Simplifying this and subtracting 5R from both sides gives us 7R is equal to 0.7, which gives us an R value of 0.1, which is part I. Part II, the value of T is going to be 1 subtract all of these other values. And all those values add up to 0.8, and so 1 minus 0.8 gives us a T value of 0.2. Part D, determine whether or not the events S and not E and G are independent. Show you're working clearly. So if 2 events are independent, then the probability of them happening together is equal to the probability of one multiplied by the probability of the other. And so let's start by finding the probability of S and not E. So if we look, S and not E are these 2 values added together. So that is 0.36 plus 0.12, which is 0.48. The probability of G, we know already to be 0.25. And so the probability of S and not E and G, so again, these two values were the probability of S and not E, but the ones that are G as well are just this value Q. So we can say that the probability of S and not E and G is 0.12. So now we need to compare this with these two values multiplied together. So the probability of S and not E multiplied by P of G. So 0.48 multiplied by 0.25, which is also 0.12. And since these two values are equal, S and not E and G are independent events.